Hello everyone. Today's topic OSPF is 25% of CCNA exam and the routing protocol you will configure in almost every real network job. Here is the lab we are going to cover today, having three routers connected in series, having loopback addresses. And all these loopback addresses should be accessible by all the routers without using the static routes. We are going to configure OSPF and we see that how these routes are developed and how our loopback addresses are discovered. And if you want to study in detail about the theoretical part, the lesson tab covers all the theory. Simulator tab helps you to visualize the difficult concept, for example, OSPF neighborship. In the quiz session, you can assess your knowledge. In the hands-on lab section, you can immediately start the configuration without any prior setup. And in the Packet Tracer lab, you will find the very sophisticated CCNA level labs, which will help you to ready for the CCNA exam. Now let's get back to our today's topic, OSPF. OSPF is a link state IGP. Scalability, fast convergence, and hierarchical routing are its key features. Before understanding the OSPF, you should understand how OSPF works. And OSPF cost is one of the basic elements which you should know. So OSPF cost can be calculated based on the formula reference bandwidth divided by the interface bandwidth. Default value of reference bandwidth is 100 Mbps. So for example, now if you are using Ethernet connection, which has an Mbps speed, the OSPF cost becomes 10. If you're using fast Ethernet connection, it will have the 100 Mbps speed. 100 divided by 100 will become 1. And if you are going to use the gigabit or 10 gigabit connection, your value could be zero point 0.1 or 0.01 in case of 10G connection, but minimum OSPF cost value could be 1. So anything above the fast Ethernet, the OSPF cost will remain 1. But for the serial connection which have 1.54 kbps speed, they have the OSPF cost of. The second most important concept you should understand before implementing the OSPF is how OSPF neighborship is developed. This is the most important thing for troubleshooting. If you understand OSPF state and role of packet deliver each state, you will troubleshoot OSPF very quickly. The simulator I have created at PacketMentor.com actually make this concept easy for you. So I highly recommend you to try that feature. So initially the router will be in the down state, and in the init state, first router having the router ID. The second router replies with its router ID and both router know each other. This is called the two-way state. So first state is the down state, then init state, and third state is the two-way state. Fourth state is XR state. In XR state, one router becomes master and second router becomes slave. And they also share a very brief information about the database description, DVD packet. Then the fifth stage is exchange state, where they shared similar to the table of contents the routes with each other. And in the sixth state, which is called the loading state, the router shares the full database with each other. The slave router requests the LSA, which is called the LSR. The master router reply with the LSU, link state update, and slave router reply with the LSR. Once this information is exchanged, the final state is achieved, which is called the full state. In case of broadcast network, DR and BDR elections occur at the two-way states. But if you are using point-to-point network, they don't have the DR-BDR elections. OSPF has 5 types of messages, which we have just seen in neighborship development. Hello packet, database description, link state request, link state update, and link state acknowledge. Then we should also know that how DR and BDR elections occur. DR, the designated router, the highest OSPF priority on the interface become the DR, and the second highest priority become the BDR. By default, every interface have the 1 priority. By default, every interface have the default value of 1. So in this case, router ID will become the tiebreaker. And router ID can be configured manually or the highest value at the loopback address. And if loopback address is not configured, then the highest IP value at the interface. Now, if you're going to understand the troubleshooting in the OSPF, this slide going to be your main slide. And I will highly recommend you to make a copy of it and keep practice about these concepts before the exam, because exam will test you through these concepts multiple times. You should be very clear that in which scenarios neighborship will develop, and if neighborship is not being developed, at which state the neighborship is stuck, and if neighborship is stuck at some state, which could be the possible causes. So these 3 questions, if you can answer confidently, your OSPF concepts are totally clear. So I will highly recommend you to practice. Like tomorrow's lecture, I'm going to do the troubleshooting using some of these conditions. And the last thing in the theoretical part today you should know is a network type. In the CCNA level, you should know about the point-to-point and broadcast network type. Broadcast network type, DR and BDR election occurs. Point-to-point do not require the DR and BDR. We'll see these things in the lab. So without further delay, let's move toward our today's lab. This is our lab topology where 3 routers R1, R2, and R3 are connected. They are connected via these networks, and each router have a loopback address already configured. So let's analyze enable show IP interface brief. So you can see that IP addresses are already configured on the interface and the loopback address is also configured. And to see show IP protocol, if there is a routing protocol already configured or not, you use the command show IP protocols. Since it is showing nothing, which means that there is no routing protocol is pre-configured. And then show IP route shall also confirm that there is no static route is configured. Now let's configure OSPF. OSPF configured in the two different ways. I'm going to tell you both in this lab. One is in the global configuration mode, config the router OSPF. You can give any process ID, one. Then network. A connected network, our router 1 is connected with two different networks, 12.0.0.0, and then the wildcard mask, 0.0.0.255, which is opposite to the subnet mask, and area 0, which is the backbone area. The second network is 13.0.0, and the same, rest is the same. And another network, which is the loopback address, 1.1.1.1, 0.0.0.0, area 0. Exit, exit, right. So this is the one way of configuring the OSPF. And now let's configure the OSPF on router R2. I'm going to use the second method. Enable config P interface G0/0. You can configure the OSPF at the interface level as well. And the command is very simple in this case, IP OSPF1, the process ID, and area 0. Similarly, you go to the second interface, G0/1, and you will repeat the same command, IP OSPF1, area 0. And right. And on the router 3, I'm going to use the same global configuration command, config T, which I have already used on router number 1. Router OSPF1 network 3.0.0.0, 0.0.0.255, area 0, and network 13, and network 3.3.3.3, 0.0.0.0.0, area 0. And right. Now you can see that I haven't configured any router ID. So by default, if you do not configure any router ID manually, it picks highest router ID on the loopback interface. We have configured only one loopback interface on each router. So the available loopback address will become the router ID by itself. So now you can see the messages that our neighborship has been developed to the full. This is what we want to see. Now let's see the route. Show IP route for SPF. You can see that router 3 has learned the route 1.1.1.1 and 12.0.0 via OSPF. This router should also learn one more route, the loopback address for router number 2. Let's see router number 1 as well. Has it learned all the loopback addresses or not? Show IP route OSPF. So again, you can see that router 1 learned the loopback address for router number 3 but hasn't learned loopback address of router number 2, which means that there could be a problem at router number 2. And the problem is we have not advertised the loopback address. Because we were configuring the OSPF at the interface level, we have only configured the OSPF at interface G00 and 01. We also have to configure OSPF at the loopback address. The command will be same, IP OSPF1 area 0. Right? And now all of our routers should also see the loopback address of router number 2. This is how you can configure OSPF. Configuration itself is very easy, but the real crux of the OSPF is to understand the theory and the prerequisites. Because in the troubleshooting, if your theoretical concepts are not clear, you will stuck with troubleshooting. Another very important command, show IP OSPF interface brief, give you a detailed idea about the behavior of different interfaces. For example, G00 state is DR, G00 state is BDR, and loopback is wait. Loopback is a different type of OSPF network. It behaves differently in OSPF. Then show IP OSPF interface if you want to analyze an interface deeply. In this case, you can see the useful information, which is the hello and dead times. In the labs, most of the time, these timers are changed, and you will see that the neighborship will not be developed. And you start troubleshooting many of the things that you have no idea about how to fix. this timer issue, you will keep troubleshooting different scenarios. Then you can see that the priority is 1, state is BDR, network type is broadcast, cost is 1. All the useful information available here. My intention for today's lecture was to cover the basics only. I will highly recommend you to practice these labs by yourself. I also highly recommend you to visit the website packetmentor.com and try the hands-on lab that give you opportunity to start immediately without any download, sign up, or configuration. See you tomorrow with the troubleshooting of the OSPF